I wanted to give you some hints on how to trace through a recursive method, which is what you will need to do on the quiz and on the AP exam. I'm going to do several different recordings. I'm going to try to do very simple to a little more complex different recursive methods. So I'm starting with a very simple recursive method here, where we have our situation where if n is greater than 0, we're going to print out n, then we're going to recursively call the test method again, passing it the value of n minus 1. It's going to continue the recursion until it gets to the point where n is no longer greater than 0. So as soon as n gets to 0, this is going to roll back up. But you're going to pass it the n minus 1, and then as it rolls back up, it's going to print again. So this is a little more involved than factorial, but it's not the most complicated recursion. It's still pretty simple. So we're going to walk through what results would we get from this, and we're going to practice using it with the value of 4. Okay, so, and I did my best to come up with some slides here in Word, and I like using this visual way of tracing through. I can do this by hand. If I'm on the AP exam, I can draw some blocks and by hand trace through it. This is similar to what was in the slideshow that I showed you from the college lecture on recursion. So I'm starting out with a value of 4. And we know that n is 4 because we are passing in the value of 4 as the parameter n. So that's nothing doing with recursion. That's just simply passing in a parameter. So n gets assigned the value of 4. In our if statement, we're checking to see, is n greater than 0? Yes, 4 is greater than 0. I have a print line. So the first thing that I'm going to do is I'm going to print the number 4 on the screen, and this is a print line. So we'll print the number 4, and then it will advance to the next line before it prints again. Then notice I am not changing the value of n here. I am simply passing to test, recursively calling another instance of test with the value of 4 minus 1 or 3. But in this instance of test, n is still 4. If I had something like this, if I actually reset n and then just passed in, that is different. That is completely different than just leaving n alone. N is still 4, but I am calling test again with the value of 3, and that's important. So as far as this instance of the method knows, n is still 4. I'm going to call again test, passing it the value of 3, just as if in my code I put test paren 3 paren. Now, this is not finished. I have not yet executed this line of code, but I'm branching out and I am calling another version of the method with the value of 3. Now, because 3 is greater than 0, I'm going to print 3. Notice it's going to be on a separate line because it's a print ln, print line statement. It's going to advance the carriage return to the next line. Then again, n in this version of the test method is still 3. I'm not changing the value of n, but I am subtracting 1 from it and passing a 2 to the next recursive call of test. But as far as this instance of the test method is concerned, n is still 3. Now I'm calling 2, test of 2, right? Now 2 is greater than 0. Again, I print a 2. The carriage line comes down to the next line, waiting to print whatever else it's going to print, if anything. And again, n is still 2 as far as this version of the recursive call is concerned, and I am passing a 1 to the next call to test. So here, test of 1, n is 1, 1 is greater than 0. I'm going to print my 1, go down to the next line, waiting to print again. Now I'm going to be calling test of 0, Okay, but as far as this is concerned, this instance of the recursive method, in here, n is still 1. I have not changed the value of n within the recursion. I'm simply subtracting 1 to pass the value of 0 to the next call. So here is test of 0. Now here is where I'm going to make sure with the code that I'm preventing my infinite recursion, because my code specifically says if n is greater than 0, keep doing these recursive calls. Now n is not greater than 0. There's no code here, there's no else or anything. So basically what happens is, because n is not greater than 0, it's not going to print, right? This is not a true condition. 0 is not greater than 0. So it comes to this brace that says, hey, there's no more code here. Well, I'm done. I am closing myself out. I am finished, and I am returning back to the last place that had control, that called me, which was this line of code right here in the instance where I'm doing test of 1. So I left off with test of 1, and now I've got to execute this next line of code. I come up, I return here, n is still 1 in here. That's why I pointed that out. That's important. Just because n is 0 here, this is done and finished. I didn't change the value of n here. It came in as 1. It is still 1. I've done my recursive call to 0. I'm finished. I'm going to come back. Because 1 is greater than 0, I'm picking up here where I left off when I called test of 0, and I'm going to print out the number 1. Again, that's a print line. It's going to reverse the carriage return to the next line. And then I'm done here, right? So that means, okay, well, that if statement's finished, return back to what called me, which was the test of 2 call. Again, and here, n is still 2. So this is where I left off when I called test of 1 with n being 2. Now I'm going to print out 2. Okay, then I'm finished. I return to what called test of 2, which was this test of 3 where n is 3. Now I'm going to print out my 3. I'm done. I come back to the very first instance where I called this test method, and I'm almost done. I come back. N is still 4 in here where I called test of 3, which is where I left off. Now I'm going to print my 4 out. And if I look at my results, I see that's exactly what I got. 4, 3, 2, 1, 1, 2, 3, 4. And I can't quite get the window to scroll like I need it to here. There we go. So I have 4, 3, 2, 1, 1, 2, 3, 4, which is the output that I predicted when I traced through the recursion manually by hand. This should help you with 1 or 2 of the very simple recursions that are on the quiz. There's a problem that asks you, it says counter is not equal to 1, print, and recursively call. That's one of the first ones on there. It's very simple. Using this methodology should help you trace through that to get the correct answer. And I will do another hint for something that's a little more complex, but this gives you a place to start. And in closing, if you have another way that you trace through recursion and it works for you, use that. This is the method I'm suggesting for people that really don't have a way to trace through, that aren't sure how they're going to figure out the value of a recursion in a question such as on the quiz. This is my suggestion. This is what I use. I do it by hand. I get a piece of paper and I draw out blocks. I walk it down and then I come back up the right side on my returns, and it always helps me to do this.